Hello everyone, welcome back to another IVHL chemistry video. Today we're going to be looking at Gibbs free energy under the topic of reactivity. So let's just write out our formula to better understand this concept. So Gibbs free energy is the subtraction of enthalpy or change in enthalpy of reaction subtracted by the temperature at which it occurs and the change in entropy that we find. So, just so that we know, Gibbs free energy is units of kilojoules per mole. Our enthalpy is also kilojoules per mole. Our temperature, as we know, will be in Kelvin, as it tends to be. But we need to watch out for our entropy, because here we need to convert to kilojoules per Kelvin per mole. This is often something that you'll have to watch out for in exams. But what really is Gibbs free energy, you might be wondering, and this is a question that we are going to answer right now. So Gibbs free energy is a measure of how feasible a reaction is, and it is determined, as we saw, by both the entropy and the enthalpy change as it occurs. So it is a fundamental thermodynamic concept which will tell you about the spontaneity of a reaction. So how this works is that if you get a Gibbs free energy value below zero, or that is negative, that tells you that your reaction is spontaneous. But if it is positive, it is not spontaneous. Pretty straightforward. But what do I mean by spontaneous? Well, exactly what the word means. The spontaneity here refers to how likely something is to naturally occur in the environment. So there are two main ways to calculate Gibbs free energy. You may either be using this equation in which you have your entropy, your enthalpy, and your temperature. But you may also simply be given the values of Gibbs free energy of all the substances present, and then you'll have to do the work as the question requires. So let's work through a little example to see what this could look like. So there are our state symbols crammed into there because of the spec points, but we are told in this question that our change in enthalpy is of 135 kilojoules per mole, and our entropy, we gained 344 joules per Kelvin per mole. So our first step, as we remember, this is not the correct unit. We are in joules. We need to convert to kilojoules. How do you do that? You divide the value by 1,000. So 344 divided by 1,000 will give you 0.344 kilojoules per Kelvin per mole. Pretty straightforward. And then step 2, you just have to substitute in your equation. So change in G is equal to change in H minus T change in S, which equates to 135 minus the temperature, which is 298 times our calculated value of 0.344. And that gives you a positive value of 32.49 kilojoules per mole. Now, step further, what would this tell you about this reaction? it tells you that at this temperature of 498 Kelvin, that this reaction is not spontaneous, it is not favorable. But if we were to say increase temperature, this reaction would be more feasible. Thank you for watching, hope you enjoyed and that this was in some way helpful.